Pretty interesting that these astronauts have had such great histories. And then STS 109 3B, a very famous mission. SN4, now we see that the Hubble is getting into its great days of, with the capabilities of new cameras these astronauts put in, that it can now look deeper into the universe than ever before. Here's my favorite part about Hubble, and that's the images. The images are just profound, and they've changed the way almost everyone on our planet sees ourselves in space. Here's my favorite, and that's what we call the Pillars of Creation. This is an Eagle Nebula. It's a summer object. Anyone with about an 8-inch or greater telescope should be able to show you this from a dark site. The Pillars of Creation are exactly that. There are stars being born at the tips, and wherever you see those little dusty things sticking out on these tall buildings in space, if you will, those are new stars being born. They're called protwigs for you science teachers out there. And who can forget the amazing pictures of Jupiter early on and after the servicing mission that brought Hubble back to life, when we watched Comet Shoemaker Levy 9 slam into the atmosphere of Jupiter and create a trail of 9 smaller meteorites. We got to see just what a collision like that can do to a planet. It left scars across the face of Jupiter, each one of the size of Earth itself. Hubble has stared deep into space, but also looked into the nebulae that are close to home, like this one in Carina. You can only see it in the southern hemisphere, which is one of the advantages that Hubble has, because it orbits the entire Earth every 97 minutes. Imagine that. For 25 years, it's been going around the planet every 97 minutes, from baking hot to freezing cold. That's quite a feat in and of itself. Again, we've learned about galaxy mergers, as we see here, 2 spiral galaxies in a gravitational tug of war that only Hubble can show us at this level of detail. And of course, my favorites are the really deep looks into space. Here you can see this great Able galaxy cluster with what we call a gravitational lens, something that Albert Einstein predicted by the bending of light itself. You know, thinking about light bending due to gravity is itself a mind-bending thing. In 1054, the Chinese wrote in their books about a great star that exploded and was bright for days, bright like the moon. This is the Crab Nebula today, and these are the remnants of that star. This is called a planetary nebula, and it's a very famous image that Hubble has made. It's not very big. It's called the Crab Nebula, and it's kind of between the horns of Taurus the Bull, if you will, if you're a constellation person. But it's up there, and again, with about an 8-inch telescope, you can see it quite clearly. You may even be able to see some color in a larger telescope. And of course, who can forget the great pictures of the Orion M42? In the center, where it's all very bright, new stars are being born, colossal stars are collapsing dust clouds, and these colors are just amazing. We've learned before Cassini launched to study Saturn, we learned that Saturn had tremendous auroras that made partial rings around the planet. These rings of fire and lightning persist for days, not like the aurora on Earth. They're much, much, much more powerful. Vast energy discharges. And we don't yet understand how they influence the ammonia and other atmospheric chemicals on Saturn. I think this is a very beautiful series of images. The Carina Nebula is one of the southern hemisphere objects that Hubble has imaged. And you can see sort of a little bit right of the center here, there's a little dark speck. It's a star being born. Except here in the heart of the Carina Nebula, there are thousands of stars being born every second. One of the great images that Hubble has ever given us is Victor 838 Monocerotis. I feel like a nerd when I even say that. Anyway, this cloud of gas and dust is being illuminated. Think of a cave. Look at it as if it were a cave. And you can see inside that cave is brightly illuminated red by these two white hot giant stars. And around the outside of the cave, you can see just the beautiful dust holding back the light from these Hubble shapes. Another famous southern hemisphere object, 30 Doradus, another star-forming factory, even more prolific than the first one I just showed you. 30 Doradus, you can see if you had a full resolution of this image, that there are countless, literally countless stars being born in the white hot area to the left. The Cat's Eye Nebula. Now, Rachel mentioned that I'm an amateur astronomer. I have 16-inch and 10-inch telescopes in my observatory, and I can look really deep into some galaxies for hours and days, much like the Hubble does. But there's no way an amateur astronomer on Earth can get an image like this unless it's a large university telescope that costs billions of dollars. The Cat's Eye Nebula, another exploding star, the remnants of an exploding star, and its shock waves pulsing out into space. And the Hubble telescope gains this power. One of the most famous galaxy images was the spiral galaxy M83, what we call the southern pinwheel. There's a pinwheel galaxy that's one of my favorites here in the northern hemisphere. But here you can see another island universe, as Edwin Hubble called it, unto itself with billions of stars. And if you think back a few moments ago when I showed you the picture of Orion Nebula, M42, and its redness, look in the spiral arm to the bottom of this image from Hubble, and you can see the same redness. Each one of those nebulae are like our Orion here in the Milky Way galaxy. We're really not alone, and the universe is a very consistent place. Now we get to my favorites. This is where Hubble pushed back the layers of time like no other telescope has ever done. The first one, Hubble pointed at a patch of sky empty of stars. And scientists were criticized for pointing to Hubble, valuable observing time, in an empty patch of sky for 10 days, saying, what are we doing? We're wasting our time. This is an important telescope. But it revealed 3,000 galaxies. A few years later, scientists now knew they were onto something. And they went from the deep field to the ultra deep field. In September 2003 until January, it looked back in time, 13 billion years, almost to the beginning of the universe, to time itself. It took 400 orbits to capture 1 million seconds of starlight. The more time you spend capturing starlight, photons of light, the more they collect on our cameras. This took us further back in time than mankind had ever seen before. The area of the sky is in the constellation Fornax, or appropriately named the furnace of these hot galaxies and stars. If you hold, this is what I'm about to show you, friends. If you hold a 1 millimeter by 1 millimeter square, arm's length, that far away, it's about a pinhole. This is what Hubble saw in the ultra deep field. Everything you see in this picture, everything except 2 stars, is a galaxy containing billions of stars. 2 foreground stars, one is in kind of the lower right and one is in the upper left. Each one of these unfathomably distant galaxies contain But then there's more. And then Hubble built on that. Hubble built on its ultra deep field to go to extremes. So we have ultra and extreme. In the ultra deep field, it was 1 million seconds. But in the extreme deep field, it's 2 million seconds, building on the previous field. From September 25th of 2012, it went back in time for 1 million more seconds, going back 13.2 billion years, only 450 million years after the Big Bang, the beginning of time itself. We call it the XDF. This exposure itself took 23 days. It's in the center of the ultra deep field. It's a smaller field. It concentrates on an area about half as big. It adds 5,500 galaxies to the ultra deep field. The faintest of these are about 10 billionth of the brightness you can see in the galaxies. Some of these proto-galaxies were the first ones ever to happen. And here's how the images stack together. In the back, more than 9 billion years ago, on this little graphic, is where the extreme deep field with the wide field camera looked. The extreme deep field, almost to the beginning of time itself, pushing back the fog of the universe. So it took people to make the Hubble what it is today. As we all know, Hubble was launched with a tragic flaw in its optical system, but it was repaired heroically by astronauts who took the technology that was made by scientists and engineers. Many of you will become scientists and engineers. That's my great hope. So these are the servicing missions and what it looks like to get up to a 24,000-pound telescope in space, going 18,000 miles an hour, retrieving it with an arm, and then go to work. Notice the tool belts. These astronauts wear tool belts, folks. They have pneumatic guns. They have battery-powered socket wrenches, and they work very hard on these things. Look at how big the Hubble is compared to the astronauts. So I want to point something out. If you look very carefully at this very large box, where it's kind of golden, little, some words are written, you can see, if you turn your head sort of sideways, that it says co-star. Kind of like the co-star of a movie. But this co-star is a little bit different, because this co-star is responsible today for the great Hubble images that we have. This is the box that contains the optical fix for the Hubble Space Telescope. I'm going to look at my paper here because I can never remember what it stands for. But COSTAR is the Corrective Optics Space Telescope Axial Replacement System. I think they made that so they could call it a COSTAR. Here they are putting COSTAR into the Hubble behind its primary mirror in the servicing bay. Again, what a view that must be. Each one of those great storms, 300 miles below, seems like just a distant world. To the people on Earth, those are probably pretty powerful storms. And finally, one of the most famous images of Space Shuttle last service mission. The Hubble team is not just NASA. European space agencies involved, Ball, Orbital, Swales, Jetson, Tall, Lockheed. I have two great friends who work for Lockheed, who are actually a husband and wife who met on the Hubble project. And I know today they're celebrating this excellent. Most of the images that you've seen here so far were, of course, they were collected, all of them, by the Hubble, but they were processed on the ground and assembled by the wonderful scientists, men and women at the Space Telescope Science Institute. These folks are the ones who do the hard work of creating the tremendously beautiful images that you see. The future looks bright. In 2018, NASA will launch the next great observatory, although this is not part of the great observatories, the James Webb Space Telescope. It's an infrared space telescope, biggest one ever. Will launch in October of 2018. Knock on wood. The best news is that if everything keeps working, the Hubble Space Telescope should remain on orbit, fully mission capable until 2020, which means we'll have about 2 years of overlap between James Webb and the Hubble. And those will be heady days. Those will be great times as the James Webb is able to push back and see through the time when the universe was essentially invisible to light as we see light. To see the very beginning of galaxies and stars, planets, perhaps even life itself. Tomorrow here at the museum, I'll be doing a hands-on activity with the ultra deep field, what's called a skywalker. This is an image that contains 800 frames, all the images from the initial ultra deep field of the 1 million seconds. There's 10,000 galaxies visible, and we'll be able to move around and observe in great detail each one of those images. If anyone can be in Dallas tomorrow around 2 o'clock, if you want to get involved in today's great 25th birthday celebration, there's lots of ways to do so. On Twitter, you can go to #Hubble25. There's a Hubble celebration event that you're part of now. And there's live Hubble hangouts at 3 p.m. 2 o'clock in Texas that you can see. I'll leave this slide up for a few moments for you to copy down some of the information. Again, back to my favorite slide, the pillars of creation, the proteus, stars being born. You know, the story of the Hubble Space Telescope, as I said, is one of a tragic flaw in the mirror. When they made the mirror, they did a great job. Unfortunately, a little piece of equipment called a null corrector was used to test the figuring of the mirror, which was accurate to much less than the width of a human hair. Well, that little null corrector was put together out of the box incorrectly by some folks. And then they tested it with the null corrector, tested the mirror to make sure its shape was just right. And the null corrector came back and said, no, the mirror is wrong, I have to fix it. And what they really did with this incorrectly put together null corrector is they disfigured the mirror. We launched Hubble, and the first images were kind of disappointing. Well, they were very disappointing. They were blurry. You can't have a blurry telescope, folks, I know. So some opticians, one of my friends, John Wood from the Goddard Space Flight Center in Maryland, got together and they made a prescription device, and they called it CoStar, like I showed you. And CoStar was what your eye doctor would call a thing that fixes the astigmatism in your eye. It was just that simple. Except you saw how big the box is. It's a giant instrument. It's just a giant instrument that weighs over a ton and a half. The engineers and the scientists at Goddard corrected a tragic flaw in Hubble with their brilliant science engineering. And then the brave astronauts took this box and installed it. And the tragic flaw was heroic. Thanks very much. I'm ready to take some questions if you have any at this time.
So teachers, if you would like to interact with us today, you have that capability. Go ahead and unmute your microphone, and we'll take questions as they come in. So anyone have a question for our guest speaker today?
Don't be shy.
classes do you take in college to become an astronomer?
Can you please repeat the question? Make sure you're standing close to the microphone, please.
I only heard something about becoming an astronomer. Can you repeat the question, please?
What classes do I need to take in college?
Excellent. Okay, what classes do I need to take to become an astronomer was the question. What grade? Well, in elementary and even through high school, secondary school, take math and science courses, get good grades, go to a university as an undergraduate where you study maybe physics. Sometimes universities have specific special programs called astronomy programs for undergraduates. I'll give you my opinion, and it's an opinion that many of my senior astronomy friends have told me, that when they hire a new astronomer, they like someone who came up with a physics degree, because that's a classical science that gives you the big picture, because you never know what you're going to run into in science. And we have something that we say that many of the people I say at NASA and other agencies say. Whenever we make a discovery, we take one step forward and then we take a little bit of a step back, because we don't always learn what we thought we would learn. We discover something and it tells us something that we didn't anticipate. And this is why a good physics background will help you. But of course, after you get an undergraduate degree in physics or astronomy or even math or engineering, then you will go on to graduate studies to get your master's and your PhD if you want to be an astronomer in astronomy or astrophysics or cosmology. I hope I answered your question. That was an excellent question. Thanks.
Any other questions?
We have a question in Plum City. How long do you plan to keep Hubble in space?
Okay, that's a really good question. The Hubble Space Telescope is planned to stay up until 2020, the year 2020. Now, interesting, we'll have a 2-year overlap between Hubble and the James Webb Space Telescope, which is the next great telescope in space. Now, here's a good one. The Hubble Space Telescope's mirror is 2.4 meters in diameter. It's a giant mirror. When we deorbit Hubble, guess what? That mirror is big enough, it's going to survive re-entry. So we have to be very careful not to have this, I think it's about a 20-ton mirror falling down on people. That would be a bad thing. So to avoid that, when we did the 2009 final servicing mission, one of the astronauts placed a bracket on the back of the Hubble that can have a rocket within it. Another robotically installed system is going to go up in the next couple of years and put a rocket on there, and the rocket will guide the Hubble to splash down probably in the Pacific Ocean. Harmless. Nobody gets hurt. Good question.
Any additional questions? Anybody else?
Yes, we have a question here on Laredo, Texas.
Hi, Laredo.
Hi guys. You'll probably run toward when you pass the boundary or be destroyed.
Can you please repeat that and kind of look up a little bit? No sweat. I heard part of it.
We'll probably run toward when it has survived its usefulness or be destroyed.
Right. It's like I said. It's going to be. It'll burn up on re-entry, and we're going to do something called deorbit. So now it's orbiting orbiting in space around Earth. Every 97 minutes, it's going around Earth, and then we're going to put a rocket on the back of it, and it's going to push it down, come out of orbit. It's going to mostly burn up from the heat of re-entry. The friction of the atmosphere will catch fire, but the mirror will survive, and the mirror will fall into the probably the Pacific Ocean where there's no heat. Good question.
Any other questions?
Does Hubble ever get
Let Laredo go first. Yeah.
Let's let Loretta go first, please.
And then we'll get back to
And then
Palm.
we'll come back to Oklahoma City. So Laredo, go ahead with your question, please.
Clean up your own mess. Don't take things that aren't yours. Say you're sorry.
does Hubble ever get Does Hubble ever get hit by space debris? Can it
Excellent question.
Space debris.
Yay, good question. Yes. Hubble does get hit by space debris, and I didn't say anything about it, but on the very first picture, when the presentation started, there's a kind of a, we call it the shutter, and it's a big flat piece of metal that's on a hinge that's folded up like this. And if we're going to a period of debris, space dust and things like that, that little thing folds down and covers the telescope just like I put a cover on the top of my telescope. Because you don't want space rocks hitting little bitty dust particles and things like that, hitting the mirror, because that would be very bad. Great question.
All right, Plum City, go ahead with your question.
Okay, go ahead. Next cloud. Do you think Hubble will be able to find like worlds that the universe, like the planets?
Very good question. Do we think that Hubble will be able to find new worlds with life? I think is the question. Hubble was designed, the answer is Hubble is able to give us great information about other planets orbiting other stars. And we call those planets extrasolar planets, or exoplanets. And you know, those are the stars that aren't in our solar system, I'm sorry, the planets that are not in our solar system that are orbiting other stars. And Hubble looks at these planets as they're orbiting their stars, and it can tell us a lot about the atmospheres around those planets. And we can tell by how much the stars wobble and how long it takes. We can tell a lot about how heavy the planet is, or how much mass it has. And we can learn from its atmosphere if it is possibly something that could support life. So yes, Hubble tells us a lot about this. Good question.
Any other questions?
I have a question. Sarah Clayton.
Hi, Clayton.
What kind of technology do you need to become an astronomer?
Technology.
You said technology. Good word. So, to be, I assume you're thinking an amateur astronomer. So you can do that from here on Earth. People have been doing that on Earth since people looked up at the stars. Really, if you want to get started in astronomy, all you need is a pair of binoculars. Most folks have a pair of binoculars, or they can get one. And you can look at a star chart that you could download off the internet. Just Google free star chart, and you could get one. You put in your location and time, and you can look up and you can see the brightest galaxies. You can see star clusters. You can certainly have a better look at the planets. Although to really study the planets, you'll need a telescope that has a greater resolution, called resolution. If you should avoid buying a telescope at a supermarket kind of store. What you should do, if you want to have a telescope, which is the next thing after binoculars, is get with your local astronomy club. Just about every town in America has an astronomy club nearby. We have a wonderful one here in Dallas, the Texas Astronomical Society of Dallas. And there are people there that will spend hours of time, probably more than you or your parents want, explaining to you what kind of telescope to buy, where to buy it. Heck, they'll probably give you one. So then once you get your telescope, then you can start to do visual observing with your eyes. You may even want to sketch what you see and be what we call a sketcher. You might move on to what we call the dark arts of astrophotography, and I'm kind of involved in that pretty much. I have more cameras than I should, and more telescopes than I should. But it's a wonderful hobby, and it's one that you'll never get to the end of that. Great question.
Any additional questions?
I have another question from Clayton, Wisconsin.
Sure, go ahead.
How many mechanical things are on the Hubble telescope?
So you got me there. We successfully stumped the chump today. How many mechanical things are on the Hubble? Okay, I'll break it down for you. I'll talk about the major systems. The Hubble contains what's called a satellite bus. That's that big thing that carries everything else in space. That's the bus. Think of it as your school bus. You have to power that school bus, so it has a power generation system, and these are the solar panels. Okay, you really did ask a good question, by the way. I like it. So you have the solar panels, and a little bit about the solar panels. You know, I mentioned that the Hubble goes around the Earth once every 97 minutes, and in doing so, it goes from an oven when it's out in the sun to a freezer when it's on the dark side of the Earth. When we first put the Hubble in space, it had these solar panels that were attached to frames. And as you know, metal expands and contracts when it gets hot and cold respectively. Well, every time it would go from hot to cold, it would get a twang. Now, a twang is not something you can have on a telescope that's looking at the pinhole of space. It can't be shaken. So on the first servicing mission, something else we did was to install new solar panels. And this, I found out from one of my astronaut friends, was actually very dangerous because they had to put the solar panels, they had to disconnect them and get them released before it got dark. Because when it got dark, it got cold, and that solar panel would go twang. And instead of having a frame to catch it, it might have sliced an astronaut's spacesuit, or worse, you know, just cut an astronaut in half. So there are the solar panels, and then that gives it the electricity that it needs to run its communication systems. Because all these wonderful pictures have to get sent back down to Earth, and they get sent back down to Earth through the Deep Space Network, the DSN, which is a wonderful NASA communication system that's in Goldstone, California, and Spain, and in Australia, and we have global coverage around the Earth 24 hours a day for Hubble data and other data as well. So then we have the telescope itself with a huge 2.4 meter primary mirror, and it collects the light. But then it needs cameras, and behind the mirror itself are all these different instruments, the advanced camera for surveys, the wide field camera 3, and so on, that are actually the sophisticated cameras that collect the photons of light. And when I say photons of light, ancient photons of light, 13 plus billion years old, that Hubble turns into pictures. So those are the major systems on Hubble. I may have left one or two out, but you know, if you build something with those systems, you can have a space telescope.
Any other questions?
From Laredo, Texas. Is the Hubble capable enough to go further out of space?
Excellent question. Very good question. So in space terms, that would be what we call boosting it into a higher orbit. And Hubble by itself doesn't have any rockets to boost itself higher into space. And when we boost it into a higher orbit, a few things happen. Okay, I hope everyone's sitting down. Young lady, please stay standing. No, I'm sorry. You can stay standing. You asked the question. But hold on to your seats because I'm about to blow your minds. In space, if you want to go faster, you have to slow down first. In space, if you want to go slower, you have to go faster first. And here's why. If you go faster, just like if you don't do this indoors anywhere, but if you have a ball and a string, right, and you're spinning it, kind of slow, it doesn't really feel like it's pulling very much on you, right? But if you start really whipping it around, it's going to pull on your string and exert more force, centripetal acceleration. Well, if you didn't have a string holding it, that ball would go much further away, right? Same thing in space. If you start going faster around the Earth, Earth's gravity doesn't hold you in as well, so you're going to go higher, you're going to climb higher. But a fellow named Kepler gave us some three really good laws a long time ago, and one of Kepler's laws say that the further away you are, the slower you're going to go. So that's why things are really different in space, in orbit, around the Earth. Great question, thank you. Yeah.
Well, I think we're out of time for today. Guys, thank you so much for joining us, and thank you all so much for joining us in science class. If you would like to attend our festival tomorrow for Hubble Space Telescope, go to the museum's Facebook page, and all of our details will be posted at facebook.com/ProMuseum. Thanks so much for joining us today, everybody. Bye-bye.
Go Hubble!
Bye.
Bye.
So,
Woo! Okay.
I got a little, I can tell, I get intense. I got a little, no, I'm not in a negative way, but I mean, I got great.
Oh, good. It's kind of fun to have space like that.
I was, it was, I looked at, one time I looked at the, like, okay, do not look at that. Start going.
A little surprising. Okay, so Max, we've got a break to our meeting.
Oh yeah, I brought it in.
Excellent.
At 9:50 every day.